This video demonstrates the Simulation Solutions Pump and Valve program, which includes a DCS schematic, as well as an interactive 3D virtual reality outside operator. Like all Simulation Solutions simulators, these two windows are fully communicable, and any move made on the DCS will also be shown on the outside operator, and of course vice versa. The Pump and Valve program illustrates water entering a tank and building a level in that tank. That water can then be sent through a pump and sent to a second tank. This second tank also builds a level, and water can either be held in the tank or sent out as an exit stream. It is important to note that both tanks are pressurized and done so with a nitrogen blanket. The control philosophy for this program allows trainees to work with various types of flow and level control schemes, as well as two split range controllers. The first tank has a level controller which controls a valve on the upstream side of tank T100. If trainees wish to build a higher level in the tank, the control valve on the inlet side of the first tank will open to allow more water into the system. Once the new level is made, the controller will set the control valve at a new output to maintain this level. So now I will demonstrate this. If we want the level to be 52% full, we will notice that the percent output of the valve will increase, and it will do so until the level process variable meets the set point variable of 52. Once this is reached, the output can be maintained at that particular output if the valve is put into manual. The exit stream from tank T100 is then sent through a pump system which contains two pumps, main pump A and spare pump B. Trainees can work through exercises where they will swing these two pumps. So either pump A will be on, which is the primary pump, or pump B will be on in the case of maintenance or if there is any malfunction with pump A. It is important to note that both pumps should not be running at the same time because this is wasteful and not needed. After running through the pumps, the flow between the first and second tank is under straight flow control. FIC 110 controls how much water is sent from tank T100 to tank T130. There is also a bypass on this controller which trainees can utilize during startup or if there are any malfunctions with FCV 110. On the second tank, the level controller will control the valve on the outlet side of the tank. This is different from the first tank, T100, because the level controller on that tank was controlling the inlet to that tank. If the trainee wishes to build a level in the second tank, the flow out of the system will temporarily decline until the new level is made. So I will demonstrate that now. If the level increases to 52% set point, we'll notice that the percent output will decrease to account for this change to the process variable. These level and flow controllers allow trainees to be exposed to different control schemes, as well as see a clear mass balance. So at design, there is 230 meter cubed per hour, or 1,000 gallons per minute, of water entering the system. There is also 1,000 gallons per minute leaving the first tank to the second tank, and 1,000 gallons per minute leaving the second tank and ultimately the system. If the levels in the two tanks are constant, then these three flows must match at all times. Otherwise, the trainee might suspect that there could be a leak in either a valve or in a tank. We can see that both tanks also have pressure controllers at the top of the vessels. These pressure controllers are split range controllers, meaning that the single output will control two valves. At 50% output, both the vent and nitrogen blanket valves are closed. However, if the trainee wishes to build pressure, the output will lower to a number below 50%, which means that the vent valve will still be closed, but the nitrogen valve will open. If the trainee wishes to do the opposite and lower the pressure in the system, the output will raise to a number above 50%, meaning that the vent valve will now open, but the nitrogen valve will close, or remain closed. Once a new pressure set point is reached, the output will return to 50%, and both valves will be closed, maintaining the new pressure. So now I will demonstrate how the virtual reality outside operator relates to the DCS screen. Here is the 3D virtual reality outside operator for the pump and valve program. On the bottom level, we can see that there are the two pumps, and we also have controllers here for all the respective flows. And then on the middle levels, we have different indicators for pressure and for flow and for levels in the tank for all of the processes. So I will go to the bottom level and I will show you how changing the pump on the outside operator affects the DCS screen and vice versa. So as we can see, primary pump A is on, which is indicated by the green pump on the DCS screen. If I change that and turn that off, and then turn on pump B, we will notice that the colors switch, and pump A will now be red and not in use, and pump B will be green and in use. We also notice that the flow is lower than the set point for the process, and that is because ultimately there was no flow between the change in pumps, which is the dead time, and the process has to account for that dead time and thus will adjust to reach that 230 meter cube per hour for the system. For more information on the pump and valve program or any other Simulation Solutions products, please call 732-389-5400 or go online to www.simulationsolutions.com.